Just want to take a quick second to talk about radian measurement. You know, I grew up with degrees, 360 degrees in a circle, and learned that when I was pretty young. I did cover radian measurement in high school, but it just didn't stick as well for some reason. I think probably because I just learned degrees earlier. But radian measurement really isn't that hard. Like I said, we start off usually talking about a circle, being able to divide a circle up into 360 degrees. When you think about it, that's really kind of arbitrary. Why? Why would we divide it up into 360? We're so used to degrees that it seems like it's common sense, but it's not. It's just that we've probably known that for a longer time. They're actually not very helpful when it comes to doing scientific type things with circles and the angles of circles, especially when you get into physics and you're talking about angular velocity, how quickly the angle, for example, is changing in a circular direction. Someone in the early 1700s, and it really didn't catch on, I don't think, until the 1800s, but someone very early on suggested it might be more convenient to measure the angles of circles in relation to how much of the arc is covered. And here's what made it so useful, especially if the measure of the arc was measured in the radius. That is, if you took the length of the radius, which of course is half a circle. The radius of a circle is from the center of a circle to the outside of to the rim of the circle. If you use that radius of a circle as the measurement, the fundamental unit of measure, then if you wrapped it around the arc, that could be a useful way to measure a kind of intrinsic measurement. It actually is a measurement that is part of the circle. It uses part of the circle to measure the circle, as opposed to 360 degrees. I think maybe the Babylonians, that's what people usually say, that maybe the Babylonians came up with 360, and then maybe the Greeks, Euclid or somebody, developed it. But really, there's nothing about a circle that says, hey, let's use 360 units. Whereas if you use the actual radius of the circle as the fundamental unit of measuring the outside of a circle, then you're using actually a part of the circle as the standard by which you measure the circle. It just makes more sense. So let's talk about the radian here.
Okay, we're looking here at a mostly eaten pizza pie. Now, what is a radian in measure? A radian is basically a measure around the arc of a circle that is equal to the measure of the radius of a circle. Now, these two pieces that are left are a little bit more than a radian because the measure of the arc is a little bit more than the measure of the radius. Okay, so what we need to do to find out what a radian measure around the arc is we have to measure the radius of the circle. So this is the radius of the circle. So 1 radian measure around the arc goes to about here. So if I were to get my pizza cutter and I was to basically cut the pizza right about there, then that would be 1 radian of measure, because that amount around the arc is equal to this radius on the inside.
Okay, so let's look at it again. This is not a perfectly drawn circle, mea culpa, but I've tried to do this with a more visible, better, little better than a pizza. And so the measure from the center of the circle out to the rim of the circle, as it were, this is the radius, and then I tried to measure a distance along the arc that was of the same length. Of course, it's curved, so you have to kind of wrap it around, but that would be the same as that, and that would be a radian. It's about a little less than 57.3 degrees in the way that we think about it. And of course, usually when you're using radians, you think of the radius going right over here as kind of ground zero, and then you measure the angle. You measure the angle as you go up from there. This is the positive direction. The positive direction is when you go this way, and then the negative direction is when you go the other way. Well, It's a little less than 57.3 degrees, as I said. Now, the measure of a radian, here's what makes it convenient. The measure of a radian will always be the same arc, because the bigger the circle, the bigger the radius. See that these two are proportional to each other. So the ratio is going to be the same. It's going to be the same amount of degrees no matter how big the circle is, because it's using the radius as the standard by which you measure the radian around the outside of the arc. So the measurement of the arc is always going to increase by the same amount as the radius increases as the circle gets bigger. This is part of what makes the radian a convenient unit or measurement. So I've already tried to give you some advantages. You don't need units. I suppose radian is a unit, but you don't need something like degrees that are extraneous. The angle in radians is going to be the same no matter what size of the circle is. So it's going to apply to all circles, and a radian is going to be the same no matter how big a circle is. Now, here's where my brain has had to take some adjustment to get into radians. Now, pi, you might remember that pi is the ratio of the circumference to the diameter. That is, that if you divide the circumference of any circle by the diameter of any circle, it's going to come out to 3.14159265535 and so on to infinity. That's going to be the same no matter what circle it is. Diameter, of course, is the distance all the way across the circle through the center. That is, a diameter is twice the size of the radius, because the radius is going to be the same length no matter where you are on the circle, right? And the diameter going through the center of the circle is going to be 2 radians. So we might put this little equation of what a pi is and put it this way. Pi equals the circumference divided by 2 radiuses. Now, what this means is, now I can multiply both sides of the equation by twice the radius, and I end up with 2 pi times the length of the radius equals the circumference. And since we're calling the length of a radius 1 radian, therefore the circumference of a circle is 2 pi radians, or half of a circle is pi radians. Again, we're using a measurement that is intrinsic to the circle rather than making up something like 360 degrees. So as I said, half a circle is thus pi radians. So if you want to know the angle in radians, basically it's going to be the measure of the arc divided by the measure of the radius. This is how we measure an angle in a circle in radians. We're going to take the measure of the arc, which is S here, and divide it by the radius of the circle, which is R here, and that's going to be the measurement of the angle in radians. Or we can rearrange it and say that the measurement of the arc of a circle is going to be the radius times whatever the angle is in radians. These are going to be helpful in various mathematical situations. Now, if you want to convert to and from degrees, which you might have some occasion to do, so if you want to get from degrees to radians, then you're going to multiply by 2 pi over 360. This makes sense, because if you have degrees, then you're going to multiply with degrees in the bottom, that is over 360, to get radians. And 2 pi is how many around the whole circle in radians, and 360 is how many to get all the way around the circle in degrees. So you see this ratio of getting around in radians and getting around in degrees, that's the multiplier to get, in this case, from degrees to radians. And we have the degrees in the bottom because we're starting off with degrees. You remember when you have a certain label, the factor label method, when you have a certain label in the top and a certain label in the bottom, they cancel out. So if you want to get from degrees to radians, you want the degrees to cancel out. And so you're going to put the 360 degrees in the bottom. If you want to get from radians to degrees, then you want the radians to cancel out. And so you're going to put the 2 pi in the bottom so that you have radians at the top and radians in the bottom, and they'll cancel out and just be left with degrees, the factor label method. Well, this has been a brief foray into radian degrees, which are not common sense if you've started off learning by degrees, but actually We probably should have learned it this way in the first place. Then it would be the common sense.